I am Anil Kumar. Let me thank all the viewers and subscribers of my YouTube channel for participating actively, writing excellent comments and suggestions. I've been receiving questions from the students on my email address given here. You're also welcome to write to me in case you want solution of your questions. In this video, we are going to discuss two questions which are related to rational functions. Now, from different parts of the world, we are having very related questions, both relate to inverse function, and therefore, I thought I'll combine the two and then make one video. So here is one of those questions. The other question is a multiple choice question, which is also based on inverse function. So let's look into these two questions and then see how do we solve them. Question number one, let me write down here. Question number one here is, consider the function f of x equals to x minus 1 over x plus 4. You need to write domain and range of the function. You need to find the inverse of this function, write domain and range of the inverse function, and describe the transformation that maps the function onto its inverse function. So the last part is very difficult. How do we describe the transformation from the function to its inverse function, right? That is the critical thing which we are going to understand in this particular video. So I hope you appreciate that part. So this is the critical part which we are going to look into. Now, the second question here is, which of the following rational function is a self-inverse function? So we're talking about a self-inverse function. Now, multiple choice test paper, we have four choices, correct? Which one is the correct answer? So here we'll understand a strategy. So I'll teach you a strategy which could give you the answer by inspection, and therefore my answer is option C. What you need to understand why. So we'll understand the concept and then apply that concept. So as you have seen in many of my videos, we are not calling them tricks. They are no tricks, right? These are concepts. So the highlight, the word is concept. So once you understand a concept, you can actually pinpoint the solution just by inspection. That is how you master the subject. So we'll see how do we solve this in this particular video. I hope you find it interesting, okay? So let's begin with the strategy on the very first question which is before us. And now we look into the function f of x, which is x minus 1 over x plus 4. So as soon as you look into this function, you say, well, the function f of x is equal to x minus 1 over x plus 4. What do you say? Well, we say that x plus 4 is not equal to 0, so x is not equal to minus 4, and that really is a vertical asymptote. So we have a vertical asymptote here, which is x is equal to minus 4, and obviously this is not in the domain. So that is one part. So you have to look into a vertical asymptote just for our reference. What I've done here is actually sketch the graph also, so that as we move along, you can see the result on a graph. So that is the vertical asymptote which we are talking about, and this is x equals to minus 4. Is that clear to you? Now, when you say about the range, in that case, what are we looking for? We are looking for horizontal asymptote, right? And how do you find horizontal asymptote? We have to say when x approaches large value of negative or positive infinity, what happens to y value? And that value gives you the horizontal asymptote. How do we figure this out? Well, we know that f of x is equal to x minus 1 over x plus 4. Now, we could take x common, right? So we get what? We get 1 minus 1 over x in the numerator. And if I take x common, I get 1 plus 4 over x in the denominator. Now, clearly, if x is a very large value, in that case, 1 over x or 4 over x is approaching 0. And therefore, what can we get? Well, x and x cancel, and we know that approaching 0. So we say that in this case, f of x, the function, approaches the value 1. And therefore, we have this horizontal asymptote which is at y equals to 1. Do you get the idea? So this horizontal asymptote you can see is not crossed. Since it is not crossed, that becomes the restriction on the range, correct? So from here, we get the range. You get the idea. So that helps us to find domain and range of the function. Now you also understand that directly from here, you can get domain and range of the inverse of the function also, correct? That's what we are going to do. To get this, we'll just swap, right? And write down the answer. So you could actually do part 1 and part 3 very easily based on this particular concept. Is that clear to you? So likewise, let's move on and now see how do we find the inverse of the function and then how do we describe the transformation that maps the function to its inverse. I hope you're finding it interesting. Just stick along and see this strategy to solve the multiple choice question also. As we discussed, now let's write down what is the domain of this function. So the domain of this function is that the denominator cannot be equal to 0. And therefore, x is not equal to minus 4 is the domain, but x can have any other real value. As far as range is concerned, y is not equal to 1, this is y, but it could take any other value. Since this y equals to 1 is a horizontal asymptote, you get the idea, right? So this is the horizontal asymptote, y equals to 1, and we do have a vertical asymptote which is x equals to minus 4. Is that clear to you? So that becomes the domain and range for f of x. Clear? Now, to find the domain and range of inverse of the function, we just swap this, correct? So this part, which is the domain, now becomes the range. So we say range is that y belongs to real number, but y is not equal to minus 4. And the range part becomes the domain for the inverse function. So they swap. And therefore, we can write the solution for 1 and 3. Okay? Now let's look into the next part, and which is how do we find the inverse of the function. So to find the inverse of the function, which is x minus 1 over x plus 4, what are we going to do? We'll write this function as y equals to x minus 1 over x over 4, and then we are going to swap x and y terms, correct? So when you swap x and y, the equation becomes x equals to y minus 1 over y plus 4. And now we are going to isolate y. So do cross multiplication, right? So we do cross multiply. And we get x times y plus 4 equals to y minus 4. Now bring the x terms and the y terms to different sides. So bringing y to the left side, we get xy minus y equals to minus 4x minus 1, right? So we did the distributive property, expanded, correct? And then we simplified by bringing y to the left-hand side, taking it as a common factor and then dividing by x minus 1, we get the inverse of the function in the form minus 4x minus 1 over x minus 1. So here is the inverse of the function, which is minus 4x minus 1 over x minus 1. Correct? So that is how you find the inverse of the function. Now from the inverse of the function also, you can actually write down the domain and the range, correct? So the domain is that x is not equal to 1, as that gives you the denominator as 0, and the range is the ratio of the coefficients of x, which is minus 4, is not included, right? So that is your horizontal asymptote, correct? So the horizontal asymptote is y equals to minus 4, and the vertical asymptote is x equals to 1 for the inverse function. Is that clear to you? And so we can write down the domain and range as we wrote earlier also, as the domain being x belongs to real number, x is not equal to 1, and the range is y belongs to real number, and y is not equal to minus 4. Correct? These are the two asymptotes. Okay. Now the question here is, can a graph of a function cross horizontal asymptote? So that is a question for you. I'd like you to pause the video, think about this question. It is a very important question, okay? So that is the question for our students. Well, if you say no, it is a wrong answer. The answer is yes. Okay? So give example. Correct. So that could be a very good question for you to think about. Okay. Now, let's move forward and look into the transformation part. Now we are going to discuss the most important issue for which I have made this video, is to understand how do we describe the transformation that maps y equals to f of x onto y equals to f inverse x. That is, we are now mapping the transformation between these two functions. How do we do that? Right? So that is what we are going to consider. Now, to do this mapping, there are different ways you could do it. You can check the transformation of each function with the parent function y equals to 1 over x. You could do that. And once you compare, and then you can actually do from the function to inverse function also. So how do we write the transformation with y equals to 1 over x for a rational function? So the idea here is to rewrite the function. So if you have the function of the form like given to us, let's say we have a function f of x equals to ax plus b over cx plus d. In that case, we have to split this function into another form, which could give us a constant plus something else on the top, which is kind of another constant, let's say numerator over some other denominator, which is going to be same as cx plus d. So we have to write it as a fraction shown here. From this, it is very easy to write down the transformation. I will here show you steps of doing the same. So let's begin with the function itself, which is x minus 1 over x plus 4. Now, we want a constant, and therefore, what have I done? We have x plus 4 in the denominator, so I added plus 4 and minus 4. That makes it possible to write one term as x plus 4 and the other term, which is 4 minus 4 minus 1, as minus 5. So that means I could split it into two fractions. One, x plus 4 over x plus 4. The other one, minus 5 over x plus 4. Indeed, this is 1. And then we have minus 5 over x plus 4. You get an idea. Directly, you could see that horizontal asymptote is 1, correct? Horizontal asymptote is 1. So from there, you get an idea how could we split it, correct? So remember, this also reflects the horizontal asymptote y equals to 1, correct? And the transformation we look into, which is the x value, is moved 4 steps left, correct? Okay, but let's look into the partial factoring, we call this, as the for the other term. So in this case, we have x minus 1 here, but in the numerator, we have 4x. So to get x minus 1, I will have to again add and subtract 4. because 4 could be factored, right? So remember that part. So again, I added and subtracted 4. Taking 4 common between the first two terms, we get x minus 4. We actually took minus 4 common, right? X minus 1, not 4, because I took 4 common. So x minus 1 is what we get. And here, combining these two terms, we get minus 5. And therefore, we could actually now write this again as we wrote here as equal to minus 4x. Let me rewrite here, right? Minus 4 x minus 1 over x minus 1 minus 5 over x minus 1. And clearly, x minus 1 cancels, giving us the result minus 4 minus 5 over x minus 1. Correct? Now look here. It is much easier to look into the transformation from fx to f inverse x in this particular form. Correct? So what do you notice? Well, what I've done here is also shown you the two graphs. Now this is the graph of the function f of x, and in blue we have the graph of the function f inverse x. So clearly what you notice here is that if you compare the vertical transformation, you're going from 1 to minus 4. 1 to minus 4 means what? It means there is a vertical translation of 5 units down. Do you see that? You're going from 1 to minus 4. So this is 1 for you, and that is minus 4. So you're going vertically down by 5 units. Correct? The other one is the transformation from minus 4 to 1. That is, we have the vertical asymptote which actually moves from minus 4 to the value which is which is 1. So do you see that? So that is the transformation which is from 4 to 1, and that is 5 units to the right. 5 units to the right. As far as vertical stretch is concerned, the y values are same, right? So the y values are same. There is no vertical stretch. The horizontal stretch or compression is also the same in both the cases. So the only transformation here is translate 5 units down and 5 units right. And that is how we can actually write down the transformations. You get an idea, right? So that is how we could actually do the questions for rational functions. If you compare the asymptotes, you can get translation. Now, this is important to understand. So comparing the asymptotes, you can get the translation, and that could actually give you an idea of what could be the transformation. And stretch factors can be seen as a coefficient of x, and those will be dealt with in different examples. However, if they are same, that means there is no change in the horizontal and vertical stretches. Perfect. So I hope the steps are absolutely clear. The question here is a multiple choice question. Which of the following rational function is a self-inverse function? So the focus is on self-inverse function. We are given 4 choices here. So let's try to understand what is a self-inverse function. That really means that if f of x is the function, then it is equal to the inverse of its function. Correct? That means the point xy is there on f of x, then a point yx is there on f inverse x. So that is the gist of it. Now, you can actually pause the video, answer this question, and then look into my suggestions. Correct? So that's what this means. Let's look into the strategies to solve such questions. Sometimes time is important and a constraint in a multiple choice, and therefore I'm going to discuss with you two strategies. Let's talk about one strategy which is obvious, and that is find inverse of each function. Now, there are four of them. Finding inverse of each of them will take some time. So that is which may take time. So sometimes that may not be a good strategy, but that is definitely a method of doing it. We'll also take this up later. Okay, so we'll check this. So check it later. Now, the other strategy here is looking into the idea that inverse function, we should have the same points, correct? So we are looking for same points. So that means we can do trial and error. Now, since we are given these functions, we see that the denominator is x plus 1, x plus 2, x minus 1, x minus 2. So we should not take values like plus and minus 1 and 2, because with those values, we cannot really calculate the values, correct? But a good value to take is what? Well, the best value to calculate to begin with is x equals to 0. Now, if I put x equals to 0 in the first case, right, we got four examples. A, if I put x equals to 0, I get y equals to what? So we get 0 plus 2 over 0 plus 1, and so y is equal to 1. You get the idea. And therefore, the point 0, 1 is on this graph. Now what we can do here is we can check that if x is 0, if x is 1, then what is the value of y? Substituting 1 here, we get what? Substituting 1, we get 1 plus 2 over 1 plus 1, which is 2. So that is 2. And therefore, this is not self-inverse. You get the idea. So you check the value for some value of x, you get a y value. Now, you can substitute that y value instead of x, right? And then again check for the y value. Do we get a point xy and yx same? That is the idea. Correct? Try it out in all these cases. The correct answer, let me tell you, from inspection is C. I'll give you a method of finding it out also by finding the inverse and proving that that is the correct answer. Now let us check in case of C, what do we get? So let's do for C. If I put x equals to 0, in that case, we get y equals to what? 0 plus 2 over 0 minus 1. So like we get minus 2. Is that clear to you? But if I put y equals to minus 2 as x, then what? So if I write minus 2 plus 2 over minus 2 minus 1, I do get 0. So you see that 0 minus 2, and then we get minus 2, 0 as a point. And that means it is self-inverse. And therefore, that is the correct answer. You get the idea. So I told you from inspection, and that is our strategy number 3. So strategy 3 is our trick. And the trick in this case we'll disclose at the end, But however, from there straight away, we get our answer. That only this kind of a function could have been a self-inverse function. And that is a test for the same. Is that clear to you? Correct. Now let's find inverse of such functions in general. Now, one of the good idea about finding inverse is instead of doing all four of them, right, which seems simpler, let's take a general expression. So we are doing general expression. So we have taken x plus a over x plus b instead of writing 1 and 2. You get the idea. So from here, we'll come to a condition which will help us to solve any question based on similar example. That's the whole idea. So to find the inverse, we'll swap x and y. So we get x equals to y plus a divided by y plus b. Cross multiply, and then we get xy minus y equals to minus bx plus b, and rearrange, right? So cross multiply and rearrange, and then isolate. To get y equals to minus bx plus a over x minus 1. Correct? Now we are looking for self-inverse. We got the function which is x plus a over x plus b, and we also got the inverse which is minus bx plus a over x minus 1. So we got this here. Do you see that? Now, if you compare these two functions, what is the condition of y equals to f inverse? So that is to say, where are these two equal? Well, by simple comparison, what do you notice? You notice that this term b should have been minus 1. So b equals to minus 1 makes them self-inverse. You get the idea. This is the only expression where b is minus 1. Do you see that? The value here is minus 1. And therefore, we can clearly see that C is the right answer. Now, if you know this strategy from this concept, in that case, such questions can be answered within no time. You don't even have to find the inverse in a multiple choice question in examination. I hope that helps. So these are small tricks and strategies based on concepts. So once you understand the concepts, you know what kind of function could be self-inverse. You get an idea. So that is how we are going to remember it and do it when required. I hope that helps. In case you want to learn from me, you can always send an email on the address given. And thanks for watching my videos on YouTube. Thank you and all the best.